And welcome to a new session. We know everything is made up of elements, and there are 118 elements in this universe. Out of them, 92 are naturally occurring elements, and remaining 26 are artificial elements. Now, study of each of these elements are of prime importance to us, and we know various compounds, molecules, in fact, several compounds and molecules are made from them, very important compounds and molecules, and their studies are very important. So, it was a need of the hour several hundred years back also to classify these vital elements in some systematic manner. For that, the classification was the need of the hour. Hello and welcome once again after a pretty long time. Now, yes, you heard it correctly. We will introduce periodic classification of elements, and Dobereiner was the famous chemist who tried to classify the then available elements into groups. He found a pattern in similarities of chemical properties and identified three elements in a group based upon their similarities in properties. He called each of these groups as triads, as in each triad there are three elements. Now, first triad, in altogether he found three triad. He was able to identify three triad. After them, I would like to discuss the first one, in which lithium was the first element. Symbol for lithium, is Li. Sodium, symbol is Na, and potassium. Okay. Now he found a pattern here. What he did, he arranged these elements in order of increasing atomic mass from top to bottom. Now, lithium, sodium, and potassium. Lithium was having atomic mass of 7, and potassium was 39, the atomic mass. He observed that the atomic mass of the middle element, here it's sodium, the atomic mass of the middle element is the average atomic masses of the first and the third element, or we can say the first and the last element. So, how he arrived? Atomic mass of sodium is 7 plus, we know average 46 upon 2, it was found to be 23.0 unit, and he was spot on. Actually, it is 23U. So, he was very successful in predicting the mass of the middle element. Now, the triad consists of, Dobereiner's triad consists of the elements chlorine, bromine, and iodine. The atomic mass of chlorine 35, and this one 127 was the atomic mass for iodine. Now he used the same formula to find the atomic mass of bromine. So atomic mass of bromine was found to be the average of the first, here the atomic mass of chlorine, and the last one 127, that is iodine. Add them, divide by 2, you get 7 5 12, 7 5 is 12, and 162 upon 2, 81. He was almost precise because the actual mass is found to be 80 U for bromine. So credit definitely should be given to him. This was the second triad. Now let me discuss the other one, the third triad, which contains three more elements. The third triad contains three more elements here. it contains calcium, strontium and barium. Now calcium atom mass is 40, barium atom mass is 137. So according to him, the atomic mass of strontium should be 40 plus 137 upon 2. It comes to 177 upon 2. It comes to 88.5. And actually, it was very close to perfection. It's 88 unit. Just 0.5 atomic mass of difference. So he was able to classify 3 triads only, and that is his drawback. Drawbacks of Dobereiner's was that he could not classify all the then available elements into triads. But definitely credit must be given to him for at least trying classification in real sense. And some more like Newland's law of octave, followed by Mendeleev's classification, and then the latest now modern classification of elements, all will be coming in the subsequent session. So be with me, and with this I conclude this session. Have a wonderful time, and bye bye, take care.